They powered the Industrial Revolution. Britain's coalfields are the symbol of a bygone era, suddenly coming to an end and depriving entire communities of their livelihood. Now, thanks to geothermal power, the old mines are shaping the future of green energy.
My uncles, my brothers, everybody I knew worked in the coal mines, including myself. I worked 21 years in the coal mines. It was a horrible job. So I was 16 when I first went down the coal mine, and it was quite dangerous. You go under a cage, which is the lift, and then you drop down 1,800 feet to the bottom. Underground, there's always faults. And where you got a fault, you'll get water coming through. That water, it was a big problem. We had to pump water because you drowned. We used to pump out about 2 million gallons a week from Dorton. All the timber we used to use would start to rot. The electrical system would break down, and it's terrible to work in. You create bad working conditions. You tend to get sores, trench foot. So it wasn't very particularly nice to work in water. I used to draw mining scenes from my experience. Everything was covered in coal dust, everything was wet, everything was smelly. I drew this one, it portrays what a miner was like. It's just dark and bloody hard work and flogging your guts out and making money. But happy. But all that was stopped by Margaret Thatcher closing the college down. I felt very angry because I thought I had a job for life. The last remains of the coal mine in the town is probably the Blast Beach. The mine is 100 metres from the beach. So we continuously dumped all the waste from the pit, the coal mine, onto the beach. 170 years of waste, all dumped on the sea. It's a scar on the environment. What's happening now with the mine is we're using the water for the heat houses. I think it's brilliant. It's like an apology, really, isn't it? It's an apology for all the environmental disaster we've done in the past, and we are using it for something good.
We're standing here on top of an old coal mine in the north-east of England. Behind me is a mine water treatment scheme, and this water at this site is pumped constantly all day round. There's water in old coal mines because once the mining has stopped and the dewatering has stopped, naturally water flows back into the mine workings. However, this water can cause problems as it often has lots of iron and other metals within it. We treat 80 litres of water a second, which is equivalent to 2 bathtubs of water every second. And this protects a drinking water aquifer that supplies 20% of the drinking water to people in the local area. So the water is warm because the deeper you go underground, the warmer you get. It's almost 20 degrees all year round. We can repurpose mine water, which was once considered a liability, turning it into a geoenergy asset by recovering heat from the mine water. Once we abstract the mine water from underground, we can then pass it through heat exchangers to recover heat from the water. The heat that we've recovered is then circulated around people's homes in a clean network of fluid, and that process is repeated and homes and businesses are kept warm. So not too far from the mine water treatment plant behind me, Durham County Council are in the process of designing and building a bespoke village of 1,500 homes. And the novel thing is all of these homes will be heated from the mine water to be able to turn what was once industry that's contributed to global warming and climate change To be able to change that back to provide low carbon heating solutions is really a perfect circular story. The northeast of England really is one of the hotbeds for the mine heat agenda.
After years of being closed, coal mines are getting a new green lease of life, and this could be the start of something much bigger. With some 23,000 pits no longer in use, their potential could be enormous. An estimated 2 billion cubic meters of warm mine water are believed to be occupying the old mines, enough to heat millions of homes. This makes mine water one of the UK's largest underused clean energy sources. Available all year round at steady temperatures, it could be a serious contender to replace gas as the main source of heating in the country. This as the government has pledged that no new gas connections will be built in homes and businesses by 2025. The investments, though, will be huge, but not enough to deter former mining communities in their bid to reinvent themselves.
We're in a heat pump energy centre in Gateshead in the northeast of England. It will be the largest heating scheme in the UK using mine water, and it will be the first one as well, so we're very much ahead of the game. We started almost a year ago boring down beneath Gateshead to find the mine workings, the best ones to actually extract the water. Basically what we have is we've got the same water coming out, we extract the heat. The heat that we extract is actually heated to about 85 degrees, send the water back, which is then reheated underground. We extract it again, take out the heat, and it continues. Sustainable source, heated naturally from the core of the earth. We've got 300 buildings, and that includes homes, which are all being connected to our district heating scheme. Several buildings which are municipal buildings. We've got hotels, offices, and some cultural venues like Sage Gateshead, which is a big concert hall. And we've also got the largest contemporary art gallery outside of London. And what we're doing is we're switching over to the mine water system. So currently in Gateshead, we've invested £60 million. I think it's good money for a green future. We've got a quite ambitious target of being carbon neutral in Gateshead by 2030, and certainly will help us achieve that aim. It's not realistic using this technology to heat the whole city, but we've got other sustainable forms of energy which we're working on, like hydrogen. Gateshead has transformed itself. What we're doing here is amazing, because actually what we did have in Gateshead is a legacy from the day of coal mines, which was obviously the dirty energy, where we were a leader in the Industrial Revolution 200 years, 300 years ago. We're now a leader in the green energy revolution of today.
The region's coal mining heritage, a symbol of the UK's industrial past, has now become an asset in the race toward clean energy. But what if geothermal water was also an untapped source of valuable minerals? We're heading to eastern France now, where lithium has been extracted from geothermal brines.
Alors nous sommes dans le nord de l'Alsace, sur une centrale de géothermie. On produit de la chaleur à partir de l'eau du sous-sol. Cette eau que nous puisons en profondeur, on sait depuis longtemps qu'il y a du lithium. Simplement aujourd'hui, le lithium devient un enjeu stratégique pour la production, par exemple, de batteries, mais pas seulement. Cette ressource en lithium aujourd'hui, elle est de 170 mg par litre. l'électricité de Strasbourg et la société Eramet, nous avons mis en œuvre un prototype pour extraire, en plus de la chaleur, du lithium de ces eaux géothermales. C'est un process particulier. On utilise le principe de l'absorption qui permet de fixer le lithium, qui devra ensuite être raffiné pour retrouver cette poudre blanche que vous connaissez bien dans l'aspect du lithium. Si on extrait toute l'année sur cette seule centrale, on pourra extraire l'équivalent de près de 2000 tonnes de lithium par an. Donc on représente rien que sur cette unité 4% de la production mondiale. Aujourd'hui, c'est bien évidemment, surtout dans des pays comme l'Amérique du Sud, l'Australie ou la Chine, que se trouve la production du lithium. Sur cette production, on va pouvoir extraire avec un procédé qui aura un impact environnemental bien plus faible que celui qu'on peut avoir aujourd'hui sur l'extraction de mines ou de salars, par exemple. Aujourd'hui, nous savons que scientifiquement et techniquement, nous savons extraire le lithium d'une centrale géothermique comme vous la voyez derrière moi. Demain, il reste encore des questions en suspens. Le coût de cette extraction et la pérennité. À partir du moment où on aura plus d'unités qui seront présentes sur le territoire, on pourra entamer une démarche industrielle d'extraction du lithium. Et en tout cas, le potentiel dans le bassin rhénan est là et ça offre des solutions et des opportunités afin que la France puisse s'approvisionner sur son territoire sans être dépendant d'importations sur un matériau stratégique pour l'avenir.
Your needs are changing, and so is France24.com.